What's up guys, Acer here, and in this video I am going to show you an inventory system that I made for an RPG game that I'm making. So here it is, RPG test level. Let me demo it first before explaining how it works. Right off the bat, I went into the level and my inventory has loaded. It remembers your inventory. It remembers how many slots you have. It remembers what armor pieces you have equipped. So let's say I take off my shirt and I put on a helmet. If I go through this change scene portal kind of thing, which what it does, it's basically this scene is linked to itself, so it just refreshes the scene. I'm wearing a helmet now. So the saving works. This is a really cool system, and I'm going to go over how it works. But there's still a couple things I have to demo. You can move the items, so that's probably expected. You can swap items like this, but you can also literally swap them. So I'm going to pick up this item, hover over this item, and press square. And now so that's a green gem and the red potion. The red potion and the green gem swapped positions. And also another thing, you can't put potions in the armor slots. You see the type right here. You see the type is 0. So a type 0 cannot go into, the type is the bottom right. So 2, 3, 4, 7, 5, there's a 6 there. But for example, type 5 goes into 5. So a type 5, which is a sword, can't go, I guess it's a main hand. It can't go anywhere else except in the type 5 slot. That's it. That is pretty much it. So let's go over how it works. This might be a long video. We'll see. I'm going to actually exit. Oh, and just to show you guys, you can exit. If you go back in, it's exactly how we left it. So it's a pretty cool system. But yeah, let me show you guys how it actually works. So we're in the object rather, and I actually have this entire system saved as a single object, but don't worry about that. So let's go over, what should we go over first? Let's go over the cursor movement. I think that's the easiest part to understand, and probably a lot of you are curious about that. So the cursor, let's look at the cursor chip first. This is how the cursor moves. It is literally just a follower. It's a follower that is permanently on, following cursor new position. The tag cursor new position. All this other stuff is for dragging and dropping. Grabbing and placing, I think is what it's called. So we're not going to worry about that. So how am I using a follower to make the cursor move like this? All I'm doing is pulsing on a tag. So let me show you. Let's say the cursor is in this slot. This slot knows the cursor is in it because right here, cursor. So it knows the cursor is in it, and when the cursor's in it, this chip gets powered on, which powers these 4 zones on. All these zones do is sense up D-pad, down D-pad, left D-pad, and right D-pad. When you press any of those buttons and the cursor is on this slot, the signal gets sent out to these 4 nodes. Where are these nodes hooked to? Well, they're hooked to where the cursor should go. So these are labeled up, down, left, right. So if you're in the spot and right is pressed, you can follow the wire and it's hooked into this position, this slot's position. What happens now in this slot? If the slot is unlocked, which it is because it's one of the default slots, this tag pulses on, cursor new position tag. And remember, the follower is following cursor new position constantly. It's following it constantly. And it's being pulsed. The 4 zones are pulsed on. So this tag is being pulsed on. Because the follower is moving at max speed, it gets there instantly. well, 1 frame, not instantly. And so there you go. You can, that's what's happening. Let's talk about how slot unlocking works. If we go down, let's say we're in the top left slot and we go down, you can see that the wire's here. But this counter is off because it's not unlocked. This slot is not unlocked. Okay? So this tag won't be pulsed on because this node is off. This is essentially an AND gate, by the way, but don't worry about that. So because it's off, the tag doesn't get pulsed on, so it never moves. It just doesn't move. So I'm pressing down, nothing's happening. Now it goes down. It's a really, really cool system. So that's how cursor movement works. So let me show you an example of why this is such a cool system. I'm going to just copy this and place it right here. Now, if you are in this slot, I'm going to hook left up to this position. And I'm going to hook down up to this one. Completely arbitrary, but it's going to work. So if we're in the top left slot and go left, now we go to the new slot. And if we go up, left, or right, it doesn't work. But if we go down, it's gonna go right here. Or here, yeah. See? It's a really cool system. You can make any shape inventory you want. It's not like math based. It's not position based. It's just plugging in wires. So as for the visual of the cursor, if we just go in here, it's pretty simple. We have a zone that checks when you're in the menu, when you're in the inventory, and when that's on, it turns on all this stuff. We'll go over. This is the dragging and dropping. We'll go over that later. This is actually the zone that turns on the cursor tag, which is, remember, it was, where was it? Here, the cursor tag, see? So this zone is what's turning that on. And this is the visual right here. It's just a number displayer with a border. It's just a border. So we can make it red. And actually a cool thing you could do is maybe dynamically change the color of it or the shape of it if you're hovering something. There's a lot you could do. But that's pretty much it for the cursor movement and the cursor itself. So now let's cover the slot unlocking. So how do you, well, let me demo it really quick again. How do you unlock more slots? Well, it's pretty simple. It's this chip right here, and it's all hard-coded. So we have a timeline. I'll go over that later, though. We have a variable. Let's find the variable. Stored in the player. We have a variable called slots unlocked, and every time you press R3, it adds 1 to slots unlocked. Where is that? Right here. So every time, so new slot, when you press R3, it adds 1 to slots unlocked. Now we're using that number right here. We're using the slots unlocked number right here. And we're dividing it. We're dividing it by 16 because 16 is the total amount of slots you can unlock. And we're putting that number, slots unlocked divided by 16, into the playhead of a timeline. Can I show you? Yeah, let me just show you this working in action. So I'm in the inventory right now. If I press R3, look what happens. It powers on that NOT gate. Then in the next one, then the next one, then the next one. And once the NOT gate is stretched all the way to the right side, so no matter how many more you unlock, the first one, the second one, et cetera, stay on. This is a really cool way to do it because with a single variable, I can save how many slots I can save which slots you've unlocked, right? Because it automatically places the playhead where it needs to be, and it automatically unlocks the slots accordingly. So I was really happy about figuring that out. This was a really cool way to do it. So let's go over just like how items are spawned and how I'm generating the items. So it's important to know that I don't have a bunch of different items. I have a single master on the ground item, and I have a single master in the inventory item. When I say master, I mean this one object can turn into, it's like a shapeshifter. It's like a I'm going to edit that out. It's like a shapeshifter. It can turn into any other object. So let me show you how that works. All right. We're going to start with initializing. When this object first spawns in, I'm just going to walk you through how, like, what happens. When this object first spawns in, it is receiving item G, which stands for item ground, data. Great. Let's go to item G data. All right. These boxes are item spawners, kind of thing. They spawn the item. They spawn the master item, and they tell the master item what object to turn into with the item G data thing. But how does that work? Let's go into it. Each item consists of two pieces of data. The ID, which is a unique number for, so each item has its own unique ID, and quantity. So quantity or level. So it depends on if the item is stackable or not. If the item is stackable, it has a quantity, which is saved in B. And if the item is not stackable, it has a level, which is the same number, which is also saved in B. There are two more important things that the important pieces of data that the item has, which is the type, which is the item type. So that's how you, like, a sword, a helmet, stackable, something like that, and whether or not it's stackable. So that's 4 pieces of data. Now you're probably wondering, how do you, but you're only sending 2 pieces of data. How do you know that? How do you know the other 2? How do you know the type and whether or not it's stackable? That is derived from the ID. It's pretty cool how I do that. Let me show you. I have a chart. I have an Excel chart. Let me show you that. It might make more sense. Here it is. Here's the Excel sheet. This is a breakdown of how the items are sorted out. So based on the ID, which is, in my system, the IDs are gonna range from 100 to 799. I could have up to 990. 999 really? 999. But anyway, based on the ID, I know the type. So, 1 to 99 is a stackable item. 100 to 199 is an unstackable item, so like a quest item. 200 to 299 is helmets. 300 is shirts. 400 pants. Manhand, offhand jewelry. So how do you get the number 0, 1, 2, 3, etc. from 200 to 299, 300 to 399? What you do is just divide. You just divide and then round. So 100 divided by, I think it's 100, yeah. Or actually, what I'm doing is multiplying. So 100 times 0.01 is 1 point something something. In this case, it's 1.0. 115 times 0.01 is, I can just do it with a calculator. I know what it is, but times, this is what I'm doing in dreams. 0.01, it's going to be, that's going to be that's just going to be 1, but I wanted to do 115 times 0.01. 0.01 is going to be 1.15. Now, to get this 1, all I do is round. All I do is round down. It's important that you round down. You just round down, and then you get the 1. So that's how I get the type from the ID. So 1, so you see, I basically am just getting the leading number. 3, 4, 5, 6, 7. And then the leading number of 1 to 99 is going to be 0, right? Because, well, let's do it, right? So 99 times 0.01. I did it again. 0.01. This is going to be 0.99. Rounded down is 0. That's why you round down, because if you rounded up, it would round up to 1, but that would be wrong. Okay, cool. So that's how we do that. How do we know whether it's stackable or not? Well, that's pretty easy, right? So if the type is 0, it's stackable. If the type is not 0, it's not stackable. So that's how I get the 4 pieces of data. Okay, and I'm sending that data through this item G data transmitter. And and how this works, basically, so like monsters, for example, or maybe you chop down a tree. This item will spawn. It will immediately emit a single time. It'll emit a single max emitted at once is 1. It'll emit a single master item. See how this is linked to this guy right here? And this this transmitter will transmit the data into this wireless receiver, like that. So in the master ground item, this is where I'm actually calculating the type, right here. So I'm taking the ID, I'm multiplying by 0.01, and then rounding down. And that's how you found the type. So that's how it works. So let's keep going, though. Let's walk through the process of this. We're initialized, right? The data, the item G data, is picked up by this wireless receiver. And this is important. The wireless receiver is not a scene-wide zone. It's this little zone right here. And if you can tell, the emitter spawns this in right on top. It's important that I do it this way because if I want to, for example, spawn in a bunch of items at the exact same time, I don't want these transmitters interfering with each other because it's probably spawning different data, and it is. So I have to do it that way. All right, let's keep going, though. This data right here that's coming out of this wireless receiver is going into a signal manipulator. And that data is going right back in to the... So the output of that signal manipulator is going right back into the freeze output. Now, what freeze output does is captures this data and freezes it. It stores it. No matter what happens, as long as this is a value of 1, which it always will be, because it's frozen, right? It will be stored. So, for example, if you delete this chip, which I do, spoiler alert, it will still be stored. Okay, so we've stored the data, right? We've stored this fat wire, which is, again, of the ID and the quantity. What do we do with it? Well, we parse it. We split it. Parse, split, same thing. So the first one is the ID. The second one is the quantity. And I already told you the ID is calculated. Sorry, the type is calculated from the ID. Don't mind this. I'll go over that later. And its output. So, okay, we've got the data, we've got the ID, we've got the quantity, and we've got the type. How do we get the object, though? How do we get the object? Well, let me show you that. What is this? Next, okay. Generate an inventory item. That's not it. I'm cutting this out. How do we get the object? So this is how we get the object. This chip right here. Basically, what we do is delete every single sculpt, and it has microchips on them, but every single object except the one that it's turning into. So remember, the ID is a unique number. So what I do, I really don't think there's a better way to do this, but I wish there was. I just have a bunch of equal signs and not gates. That's all it is. So the ID is taken from this, right? So ID is wired into here, and then that's wired into this. And it's sent into all these microchips. Yes, I could have done it in one microchip, but this way is really orderly. It's a lot more organized. There's going to be a lot more than just 2 sets. There's going to be probably 10 or so in each one. So the ID is, let's look at the non-stackable, let's look at the stackable, for example. The ID is wired into here, and it's wired into each of these calculators. And I just check if it's 1, I check if it's 2, I check if it's 3, I check if it's, I think this is going to be 500, 501, etc., etc., etc. Now, if it is, let's say it is equal. Let's say the ID equals 1. The NOT gate will turn off. This NOT gate is hooked up to, I believe, a destroyer. Yep, it's hooked up to a destroyer. If it's off, it doesn't destroy itself. Now it's passed through a node first because this whole chip is going to be destroying itself. So if the chip destroys itself, the wire destroys itself. But the node will always be here, so this destroyer will just never, it'll just never go off. Okay, so that's how we destroy, and again, so let's say it doesn't equal. This NOT gate will be on. So an off signal into a NOT gate will be on. Hooked up to the destroyer, the item will be destroyed. I have a pulse delay. So I have a pulse hooked up to a pulse at off. So this is a single frame delay. I could have used a timer too. I probably should have used a timer. I'm just going to use a timer. So 0.033 in a timer is a single frame. Okay, so after a single frame, this chip destroys itself. All of this stuff destroys itself, as well as this initializing chip, which is why we have to save the data here instead of in the chip, because we destroy this too. So that's how the actual item is chosen. And for individual items, I might have... Well, actually, these items are on the ground, so I'm probably not going to have individualized logic for them. But, I mean, for example, I could make the item glow or something. I don't know. I'm not sure. I probably don't need this logic in here, to be honest. But anyway, let's keep going. So what happens when we pick up this object? What happens when we pick up this object? It needs to generate an inventory object, right? So this ground object needs to generate an inventory object. These are not the same thing. It doesn't just teleport into the inventory. So using the same method of transmitting the data. So I'm taking... See how I'm combining it back? I'm combining these two things back into a fat wire. And I'm putting it into this. Spawned inventory item data. Okay. So when I press inventory pickup item G. So when I press square over top of... So when I'm hovering this item... When this item's on the ground and I'm hovering it, like I'm standing over top of it, and it's the next item I'm about to pick up, and then I press square, it will emit the master inventory item, and it will also be transmitting the data. It'll be transmitting the data, and this item picks up that data. And I'll explain how that works as well. But it's spoiler alert, it's the exact same method. It's the exact same method. After, I think it's 0.2 seconds. Yep, after 0.2 seconds, which is, I know it's hard-coded, but that's just enough time for the data to transfer. This ground item destroys itself. And before we're done with this, there's one more thing we need to do. We need to go over. So, how do you know that this is the next item that's going to be picked up? Well, it's this chip right here. We're using exclusive gates because we only want to pick up one item at a time. And, well, how does this work? Basically, we're using a zone. We're using a zone, which is on the player. Right here. I think. Yep, player pick. No, not here. Is it this? Is it any of these things? I don't think it's any. Is it this? Yeah, it's this. Here we go. Here we go. We're using a zone that's a cylindrical zone around the player that's set to a fall off. So Z doesn't matter, but it's set to fall off. So that means the tag, when the zone senses the tag will actually emit a value from 0 to 1 based on how close the tag is to the zone. Okay? So based on that knowledge, we can set the priority of the exclusive gate based on how close the tag is to the player. Because we want the player to pick up the closest item, right? So the exclusive gate's priority is set to the tag's value, and the closer the tag is to the player, the higher the number. So the higher the priority. And the exclusive gate only turns on when the tag is actually being sensed at all. So this NOT gate is going through the exclusive gate, and this signal will only go through if the exclusive gate is open. I've already explained when the exclusive gate is open. What happens when this signal actually does make it through? It checks if you have the item, if you either have the item and it's stackable, or it checks if you have a new slot. So if either of these things are true, if you have an open slot or if the item is owned and stackable, you can press square and you can pick it up. So another thing, this is complex stuff, guys. Another thing is, how do you know? So what if your entire inventory is full, but you're picking up a helmet and the helmet slot is open? Well, you actually know that. So let's go into here. How do you know if it's an open slot? Right here. Right here. It knows, the slot knows, this is the helmet slot. The helmet slot knows if the next item you're picking up is the same type as the slot. So I think this logic is actually in all of it. Or actually, it doesn't have to be, does it? No, it doesn't have to be, because anything can go in these. But for these 6 slots specifically, it checks if the item you're about to pick up is the same type as the slot. And if it is, then slot new item position is on. And this priority is set really, really high because I want you to equip it before it goes into your general slots. But okay, so that's how we know if a slot is open. And it goes into here, which emits it. I already went over this. What about this? This next pickup, this is how it knows, right? It's transmitting the next pickup data. And also, here's where we can do glow. So the item glows. I actually didn't finish this because I'm going to do it a different way, but if you're hovering the item on the ground, it glows. I probably want to do something else, though. But anyway, that's how the master ground item works. So what happens when the master inventory object spawns in? Well, I really don't have to go over... Well, hold on. Maybe I do. Okay, no. I don't really have to go over how the data is received. It's the same way, right? The data is being received. Oh, but one thing I should mention, which is important. So you probably noticed that I'm receiving the data here with a receiver, but I'm sending the data with a receiver. The reason I'm sending it with a receiver here is because it's scene wide and it doesn't matter. I'm receiving it with a receiver here because it does matter. It needed to be this little zone. It does matter. Why are you sending the data with a receiver scene wide, you may ask? Because you're only adding an item one at a time. You can only pick up one item at a time. So to have the data scene wide, it just makes more sense, in my opinion. It's just easier to work with. Otherwise, you'd have to spawn the inventory item directly on top of this, and it just gets kind of messy. So it's just easier to do it this way. But Acer, you're spawning all the inventory items at the same time. I'll cover that. Don't worry. Okay, so the data's saved. Same idea. And then this is the ID. We're using the ID. This is the exact same method. Okay, this is it's like the exact same logic. So I'm not going to explain that. But let's just start with the initialized chip though. So this is a little more complex. There's a little bit more going on. And it has to do with this stuff partly. When you're initializing, okay, so if you're loading, so this means in the beginning of the game, there's just no initializing. It just shoves the item right into the inventory. But let's assume you've picked up this object. So for 0.1 seconds, it's going to be, actually, I think it's 2 frames. Yeah, it's 2 frames. For 2 frames, it's going to be initializing. And then after these 2 frames, it counts this counter up, and we're done initializing, right? It's initialized. What happens when this counter isn't counted up? This NOT gate, and then I'm explaining this really poorly. Let me cut that out. Okay, so for 0.2 seconds, this counter will be off. When this counter is off, this NOT gate is on. When this NOT gate is on, a couple things can happen. A couple things do happen. This is basically the initializing period. This is This is how the inventory object, it's something that needs to happen once when it spawns in and then never again. So the first thing is checking if it's a duplicate. So if this object is a duplicate, it needs to just delete itself, right? And then it needs to add its quantity to the object that's already in your inventory. So if, for example, you have a stick, right? You have 2 sticks. If I pick up another stick, which you can see the number 3 right there, you might not be able to see that, but if you pick up another stick, it's not going to place it here. It's going to add to 2. So it's going to be 5. See? Quantity 5 right there. So that's what's going on there. Because it's stackable, right? Okay. What else? What else? Well, this is wired into this. And this is wired through here. And that's into D. What is D? I'm skipping ahead a little bit, but we should go over this. This places the object in the next open slot. So do you remember the tag new item position? You might not. You probably don't, to be honest. In any slot, there's this chip, and it's the new item position tag. Only one of these are on because of this exclusive gate. If you didn't know, only one exclusive gate in the entire scene with this name can be on at a time, and it will teleport this item to the next open slot. And the next open slot is, we've already gone over this, so it's calculated here. It's just hard coded basically. Actually, for the armor slots though, it's not hard coded, but again, we already went over that. Okay, so it teleports into the next open slot, and then we get sent to, where does this wire go? It gets sent to A. A is just placed, right? In placed, we're just teleporting to the slot. Each slot has a slot tag. And if you're teleporting to a tag that exists multiple times in the scene, it will teleport to the closest tag. So I'm using that. I'm taking advantage of that here. What else happens in placed? I guess we can go over this. The tag inventory item, a bunch of just tags turn on. Hover type, yep. If the cursor is hovering, so the data gets transferred, or the type data gets transmitted. This is used somewhere else. What about this? Equip node. Okay, so if it checks if it's equipped, and if it is, it tells the item to be equipped. There's some other stuff going on. We'll go over that in more depth soon, very soon. So the item has been initialized. What happens next? The data needs to be saved. Or the data has been saved, right? The data has been saved. So right here, this is the initialized finished, right? The initialized finished. While initializing was going on, the data has been saved. We've already gone over how this works in this signal manipulator. It is then split. It's parsed. Right here. So this ID and this quantity. And so that's here with the ID and the quantity. This gets a little more complex. The quantity is here. Now, initialized quantity. The quantity needs to be, so for items that have a quantity, which means they're stackable, it needs to be saved in a looping calculator. This saves the number, and we're able to easily add to this looping calculator. Because again, if we pick up the same item, we need to add to the stacks. So it starts at 0 and it's initialized, right? So the quantity gets passed through this node and gets pulsed into this calculator, which saves the data. And then after initialized, this chip turns on, which adds duplicate quantities. So if you pick up a duplicate, this chip senses that, tells the duplicate to destroy itself. Remember that? It was right here. So right here. Inventory duplicate, destroys itself. And it adds the duplicate quantity to itself. So it steals all its quantity. That's how that works. And as for the type, this is calculated from the ID. And as for the stackable, this is calculated from the type. And then this data is transmitted. I'm going to be honest, I don't even know if I use these. I think I use it to display the data, but that's about it for now. But anyway, so this data is passed out using nodes. So we've successfully saved the data in our item. So what else do I have to go over? We've went over how the data is saved. We need to go over how the data is saved within the inventory item. There's 3 more chips, right? So how the data is saved in a variable. Just checking. This just checks if the item is owned. So it checks if the next pickup ID is equal to this ID, and then it turns on the tag if it is. And then the save data. It's combining. So this is how the save data works. This is pretty cool. It's combining the ID and the quantity in a single number. So it's adding the ID to the quantity, and the quantity is being multiplied by 0.001. So it's being divided by 1,000. So that essentially moves the ID. I'm sorry, it moves the quantity. Or wait, is it the quantity? Yeah, it moves the quantity to the right of the decimal place. Because remember, the quantity is from 0 to 999. Well, not 0, but it's from 1 to 999. So it combines that into one number, and it transmits it. It transmits it to a slot. It transmits it to a slot right here. And that is, I'll go over this. Well, actually, I'm not going to go over this later, so I'll just go over this now. I'll go over this part now. I'll go over this later. It transmits it to this item save data, and it stores it in this variable modifier, in a variable, using this variable modifier. So, for example, this is slot helmet, and that's how it's saved. That's not how it's loaded. How it's loaded is, I'll go over that soon. Okay, then we went over this. How about this? So this is gonna be, this is some tricky stuff. This is the grabbing, placing, and swapping. Okay, so first off, why do I have a selector? I have a selector because I only want one of these microchips to be kind of activated at a time. These 4 microchips do 4 different things. If this one is on, if we're in A, the object has been placed. All right, the object is actively teleporting to the nearest slot. It counts as an item. It checks if it's equipped, and if it is equipped, it activates. It tells the visuals, right? It tells the item visuals to appear. What else? Oh, and it transmits the type when the cursor's on it. Now, all this stuff is used for other things, but that's just what happens when this item is placed. Okay, what about when it's grabbed? So what happens when we're in state B? When we're in B, a couple things happen. This keyframe just makes it glow, but the item's invisible, so this keyframe does nothing. I don't know. I probably should delete it, but I'm kind of scared to delete it, to be honest. This teleporter turns on. So instead of, when we're in place, it's teleporting to a slot. Instead of teleporting to a slot, we're teleporting to a tag called grab position, and that's in the cursor right here, grab position. So it's just slightly up and out. So let me show you really quick. See how it's up? So that's the difference between grab position and the slot tag. Okay, and what else? It's also transmitting some data. The type. It's transmitting its type, and it's called cursor grab type. So it's transmitting the type that the cursor is grabbing, basically. Okay, what else? Swap. When we're in C, okay, so what is swap? What is swap? This is some tricky stuff. This is a really cool feature. Swap is this. We have an item here, and we have an item here. Let's put it here, actually. Actually, just for fun, let's put it all the way in the bottom. If we pick up this item, drag it over this item, and press square, which is the swap button, it will swap the items. It will put this item here, it will put the shirt here and the helmet, which we picked up, in the shirt's position. So this is a really cool, I'm really glad I got this working. So this is how it works. It's pretty simple, actually. You know what? It's not as bad as you think. So what happens is that the object you're carrying in the cursor. Wait. Oh, that's not true. That's not true. So this object right now, if this gets activated, this object. So to get into the swap state, the object needs to have been placed. So look, to get into C, let's follow this wire. It needs to have been in placed. You cannot swap from the cursor. You can't get into this microchip from the cursor. So let's say it's placed down. It teleports to the slot previous. Then after a pulse, a pulse goes off when we get into this state. It teleports, and then when the pulse goes off, so pulse at off, another pulse gets sent, and we get put into state A right here, which is placed. So it begins placing itself again. Now, what happens if we're the object in the cursor? If we're the object in the cursor, how does that work? That logic is actually done in the cursor. So the cursor, so let's go into the cursor logic now. If the cursor is, this is kind of complicated, but that's okay. If the cursor is grabbing something, if the cursor is currently grabbing something, right, okay. Oh, I didn't label my nodes. I'm sorry, I didn't label my nodes. This node is when it's placed, when it's placing, right? Yeah. So this always label your nodes, people. This node is when you're placed, and this node, or basically when you have nothing, and this node is when you're grabbing, I believe. Yeah, grabbing, or from D you're replacing. Yeah. Okay. All right. So when you are grabbing this, it takes a little bit. So when you're grabbing for at least 0.1 seconds, you're able to swap, right? You're able to get into the swap. So let's see how do we get into the swap? How do we swap? Yeah. How do we swap? We need to press the button, right? We need to press the swap button. We need to be hovered over an inventory item, hovered over an item. We need to have a slot previous that's actually available. I'll go over that shortly. So there needs to be a previous slot. And finally, the previous slot needs to be legal. So you can't swap a potion into a sword slot. What else? There's two more things. You need to have been grabbing something. So you need to be grabbing something, right? Which is this wire. And finally, the slot of the thing you're grabbing that you're placing it into also needs to be legal. So the previous slot needs to be legal, and the slot you're putting it into needs to be legal. So if all 6 of those things are true, you get to swap. So what does swapping mean? Well, two zones power on. That's it. Cursor swap and item swapped. What does this mean? I'm not entirely sure. I'm pretty sure I'm pretty sure cursor swap is just for a sound, I think. And then inventory items, or no. This is the sound. This is for the sound, and I'll prove it. I'll prove it. Here, look. Let's go into sounds, global sounds. Inventory item swapped. Yep, that's all it's used for. It's just used for a sound. Here, though, cursor swap. This is what's used in the item right here. Here, I believe. See? Cursor swap. So that's how you know when something should be swapped. I will go over the rest of this shortly, but I had to go over that so you know how things are swapped. What else? So there's one more. Place in next open slot. I already went over that. The only way you can get into this microchip is if you're initializing. Remember that node a while back? It's if you're initializing. So that's the inventory item. That is the inventory item. That's actually all of it. The visuals are, it's literally just, these are the visuals. This is really trivial. I'm just getting the data. and I'm displaying it. It's really trivial. Okay. The cursor. So the other end of the equation, the other side of the equation. This is where I put most of the logic. Why? Why did I put most of the logic into the cursor? This is a really important thing. It's because there's only one. There's only one cursor. There can be a possible 26, 20 plus 6, items in your inventory. So every gadget, every piece of logic I put into this is multiplied by 26. So that's why like this side is relatively light. It's really cheap actually. This is all relatively cheap. This is where the heavy stuff is. This is where I tried to put as much logic as possible. So what's happening here? What is happening here? Same idea. It's a state machine, right? There's 4 different states. You can be placing or default, right? Default state, you have nothing. So you've just placed something. There's nothing in the cursor. Grabbing, the cursor is actively grabbing something. Swapping, so the cursor places an object and it's swapping. You know what swapping is. The 2 objects switch positions. Or replacing. So replacing, I haven't gone over that yet. Replacing is this. Oh, I need 2 objects to replace. So replacing is this. This is what replacing is. When you place and pick up at the exact same time. All right? So let's start from the top. Placing. When you just enter the placing state, cursor placed, right? So this tells the item. Remember this? Oh, I don't even think I went over this part, but let's actually, you know what? It makes more sense to go over this part. How you actually get into these states while going over this. So cursor placed. So you get into the placed microchip. You get into the placed state when what? When the cursor tells it to, and when you're in the grabbing state. So when this item is being grabbed, and the cursor tells it to place, it places. When does the cursor tell it to place? That gets a little more. Complicated. We'll go over that after I finish these 4 things. And then this is just for the sound, right? Inventory item place. That's just for the sound. Okay, what's next? Grabbed. Same idea. Cursor grabbed. And then this is, and set previous. So that's how the previous is set. So let's go over the grabbed first, though. Cursor grabbed is right here. Cursor grabbed. So when you're in the placing state and cursor grabs you, you get into the grabbing state. It's that simple. Now, setting previous. What does that mean? What does that mean? When you grab something, it needs to remember the spot you grabbed it at, because you could potentially swap the item to that spot. So so how does that work? So inventory set previous. It's a zone that's local. It's a local zone. Let's just go into a slot. I think it's right. No, is it right here? No, I think it's right here. Yeah, previous, right here. So set previous, right here. It counts this counter up, which turns this tag on, saying there is a previous slot. And also it is now transmitting the previous type. So that's how you detect if it's a legal slot or not. So basically when set previous is turned on, when this is pulsed on, this tag is permanently turned on until it's turned off right here, item placed. So once the item is placed, the previous slot is turned off because there's no previous anymore because the item is placed. Okay, what's next? Swap, I already went over this. It tells the item to swap. And then, this is important, 1 frame later, so Paul set off, 1 frame later, it goes back to the place, state. So it tells the object in the inventory, it tells the object that is placed to swap. 1 frame later, it tells the object in the cursor to place. So let me show you that. You can actually see the delay. All right, watch. You can see it swap, then place. Watch. I'm grabbing it, and then I'm going to press square for swap. See, you see the delay? So that's how that's working. Okay, what's next? There's one more left. Replace. Replace. This is a little interesting. This is a little bit interesting because you have to both place and pick up at the exact same time. So that's what we do. We place and we grab. We place and we grab. That's it. That's it. Now, why isn't this its own state? Like, why? So it is its own state, right? It is its own state. But why doesn't this microchip connect to D, right? Complicated. Don't really want to go into it. Basically, you should be able to replace while grabbing. It's weird. I don't really fully understand it. I'm going to be completely honest. Maybe, you know what? Maybe I'll understand it once I go over this logic. Because, to be completely honest, I forgot. So now to go over the state-changing logic. This is pretty involved, I'm going to be honest. But let's see if I can explain it pretty well. So first, how to get into placed. Here's one. Initially, it's going to start in place. So this just ensures that it starts in the first state. This NOT gate into a pulsar, right? How else? Well, we've got an AND gate with 4 things. So first, you have to press the grab button. There also has to be an item. Or no, this is place. Sorry, this is place. So yeah, you still press the grab button. It's the same button, grabbing and picking up. There has to be no item under, like, so you're holding an item, right? You're holding an item because because look at this wire. It's if you're in grabbing. So you have to be grabbing an item. And there can't be an item under. So you've pressed the grab button, you're grabbing an item, and there's no item in the slot you're hovered over. And finally, it's a legal slot. How is it a legal slot? It's just checking if the grab type is the same as the slot type. It's really, really simple there. Or if the slot type is equal to 0. So, because again, if the slot type is equal to 0, anything can be placed. If those 4 things are true, you get put in the place state. And remember, in the place state, it places your item that you're grabbing. Okay. Grab state. How do we grab? This is really simple. Really, really simple. You press the grab button. There's an item. There's an item in the slot. B is if you're placing. So yeah, it's called the place state, but really it's like the default state. So if you're in the default state, basically you're not grabbing anything. And a timer. So, okay, this makes sure... I'm not sure. This was like something to fix a bug. I might not need it. I might need it. I don't know. But let's not worry about that. Then we grab. Yeah, so this timer... What is this just set to 1 frame? This is just a 1 frame timer. Oh, I remember. What was happening was that when I started up the game, the cursor would just automatically grab something. So I put this 1 frame timer here that prevents that. It was the weirdest thing, but so yeah, that's what that is for. Swapping. So remember, swapping is 2 items switching spots. I've already gone over this. Rewind the video. Okay. Finally, this is none of these are labeled. Replacing. So remember, replacing is you're grabbing an item, you're placing that item on another item, and then you grab the item that was that was already placed down. So to do this, you have to press the grab button. There needs to be an item under the item under the cursor, in addition to the cursor grabbing an item. So you need to be grabbing an item, and there needs to be an item in the slot. And finally, the slot needs to be legal, right? And then you get put in the replace. You may be wondering why grabbing is wired from D and B. That's because when you press B, that means you're grabbing something. And when you're sorry, not when you press B, but when you're in B, that means you're grabbing something. And when you're in D, you're also grabbing something. It's a different type of thing. You're replacing, but you also end up with something in your cursor. So that's why it's in this. That's why it's wired into this node. So there's one more thing to go over, and that is loading. That is loading. So when I say loading, I mean spawning in your items that were saved. All right. And just a quick recap: saving is as simple as just pulling the data from the slot and putting it into the variable using a variable modifier. And we're only saving when the inventory is not open. That's important. Oh, yeah, yeah. Okay, so that is very important because you don't want to be able to like save items that you were grabbing or like overlap items with the cursor, then exit the game. So as long as the menu's not open, you can just continuously save. But anyway, this is where the data is saved, so we need to load the data, right? We need to load the data. Just to show you how this works. So if you remember, the ID is saved to the left of the decimal, so 1, for example, and the quantity is saved to the right, so 9, for example. So if we play, we're gonna have we're gonna have red potion ID 1, and 9 of them, a quantity of 9. 900. Why is that 900? This is good. This is a learning thing. My bad. Because 900 is 900. To get 9, we would do 009. After we reset the scene, of course. See? Quantity 9. So the max quantity is 999. So, see? You can't go any higher than that. I haven't tried. I don't think it would work. I don't think you could go 4 numbers past the decimal place. Anyway, so how does this work? How are we loading? How are we creating objects from this number? Let me show you. Let's go into a slot. It's all done within the slots. So this logic is copy and pasted 26 times, but we delete it. We delete the logic after it's done. So this is it. This is how loading is done. We take the data. We take the data and we do some stuff to it. To get the ID, remember we just round down. And we already have been over this, but I'm just going to go over it again. We round down. And then we put it into A. To get the quantity, we multiply by 1,000. Yeah, we multiply by 1,000 and then take the remainder after division by 1,000. Which gets rid of the three IDs, right? So here, let me show you guys this really quick. Let me visualize this for you. So the number starts as 1.999. By multiplying by 1,000, the number becomes 1,999. By taking the remainder after division of 1,000, the number becomes 999. Because you're seeing, I don't want to explain that. Look it up if you don't know what that means. Okay, so we've successfully split it. We've successfully gotten the quantity out, and we've combined it. So now we have the data. Now we have the spawn data, and it's exactly the same as this. See? Oh no. Oh, it's not. It's not. It's exactly the same as in here, because remember, it's going right into the inventory. It's going right into the inventory. See? Look. Spawned inventory item data. Spawned inventory item data. We got an emitter. We have an emitter. It's the exact same thing. It's the exact same process. What else? We check if... Oh, this is important. We check if there's any data at all. If there's no data, if the calculator equals 0, we destroy it. We destroy it either way, but we immediately destroy it. So, what if there is data, right? If it's not 0, we emit the item. If there is data, right? If there's no data, we emit the item. Then after, I think, 0.2 seconds, we destroy it. Yep. And here's a little trick. we have a node connected to nothing that is connected to this NOT gate. So what this does is after this works, right, after the data is spawned in, it allows the NOT gate to turn on, which allows this to save, which allows the item to save. We don't want it saving before the item is loaded. That was a fun thing to bug fix. What else? There's one more thing. There's one more thing to note. How am I spawning all these items at the same time? I'm using a local zone. I'm using a local zone. So remember how I didn't use that? I used a global zone here. I'm using a local zone here. So there's one more thing I forgot to go over, and that's how the actual visuals, how the visuals appear on your character, right? So you put the shirt on, and the shirt actually appears. How does that happen? It's really simple. Really, really, really simple. We have everything here. All the visuals are here outside of this object. And so remember, everything gets deleted except the object. Well, we have a switch. We have a switch, and if this switch is on, so how does the switch turn on? In here, we go to grabbed or placed, right? Placed, yep. And it checks if the item is equipped, and if it is equipped, it powers on this keyframe, and this keyframe powers on that switch. That's how that works. I didn't mean to do that. Okay, and this switch is hooked into the shirt. The shirt is, this is the actual shirt on the player. So when the shirt receives power, it will, well, okay, so why is the shirt here? It's just this keyframe, right? So if this keyframe gets deleted, they're all in place. So I have the keyframe though, because it's just, it's easier to work with, right? But so we can assume this shirt is in place, and it just gets powered on. It's that simple. It's just powered on if it's equipped, and powered off if it's unequipped. But it's always in the right spot. It's always in the right spot. So that's it, guys. That is this entire system. Oh, one more thing. One more thing. Super simple. We've got a little state machine. That's not... The state machine, this isn't what the tutorial is about. But when we're in the loading state, we have a little loading screen, right? We have a little loading screen. That is part of the inventory. And the loading screen is real. The loading screen is real. So how is it real? Well, if this chip is alive, right? If this chip is in the game, that means it hasn't loaded yet. So this tag, loading, is there. And you stay in the loading state from loading. You stay in the loading state until loading, the loading tags, the amount of loading tags, right? The number of detected loading tags equals 0. What I actually would make more sense. It doesn't, you just need one. So honestly, this would make more sense. If there are no more loading tags sensed. So if this is 0, bam. That makes more sense. If there are no loading tags sensed, you change states. The loading is finished. That's everything related to the inventory. If you have any questions, guys, any questions at all, please leave a comment, and I will answer you. If you need more help, I stream dreams on Twitch every Tuesday, Wednesday, Friday, and Saturday. I will answer any questions you have. I will demo anything you want. This is a really complex system, so I don't blame you if you didn't fully understand everything. If I'm not streaming, I have a Discord and Twitter, and the link is below. But anyway, guys, this was a long video. I really hope you learned something. Took a while to make, but I hope it's worth it. I hope it definitely will help the community out. I hope you have a great rest of your day, and hopefully I'll see you later.
I just wanna be with you. I just wanna be with you. Yeah.